Welcome back to our YouTube channel, Joseph Jobs Kaira Chemistry channel. We are continuing with electrolysis, and this is our lesson 4. This is our lesson 4 for O-level senior 3 stroke senior 4. Today, about electrolysis, I want us to look at an experiment to distinguish between strong, weak, and non-electrolytes. How can we distinguish between strong, weak, and non-electrolytes? Remember, as I was introducing you to this topic, we said electrolytes can be strong or weak, and we said some other compounds are non-electrolytes. For example, we looked at diesel and petrol being non-electrolytes, although they are fuels. Okay, what do we need for this particular experiment? For this experiment, we shall need connecting wires. We shall need connecting wires. We shall need iron nails. The iron nails, we shall see their role. We may use them as anode and cathode, but we shall see how useful they are going to be in this experiment. We shall need a 6 volts DC power source. When you talk of a 6 volts DC power source, you can use batteries, you can use dry cells. How many could they be? Remember, each dry cell is 1.5 volts, if I'm not mistaken. So if each is 1.5 volts, that implies 2 of them are 3 volts. So we may need 4 of them to make 4 dry cells, each 1.5 volts. Will give us the 6 volts DC power supply. So you'll see the amount of energy we need for this experiment to give us positive results. We need a switch. We need a switch for this experiment. And we also need substances under investigation. Number of them. We need substances under investigation. It is these substances that we shall see whether any of them is a strong, a weak, or a non-electrolyte. Okay, so we have ethanol. We shall need ethanol. Most of you, especially those who follow Mother Mary and Jesus Christ, know what ethanol is. I'm very sure. We shall need sugar solution. Sugar dissolved in water. Any concentration of sugar solution can work. We shall need urea. We shall need paraffin. Some people call it kerosene. We shall need water. The usual water. Any water you get from anywhere. We shall need distilled water, which I talked of as deionized water when I was introducing you to this topic. We shall need cooking oil. These are common substances that everybody can get. We shall need sodium hydroxide solution. We shall need sodium hydroxide solution. I think let's also try to use ammonia solution. We shall need ammonia solution. This one is good from a reagent bottle containing ammonia and dissolve it in some water. We shall need dilute sulfuric acid. dilute sulfuric acid made by diluting a concentrated stock solution of sulfuric acid from its bottle. We shall need sodium chloride solution. We shall need sodium chloride solution. This is made by dissolving sodium chloride in water. How many substances are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. About 11 substances. There are 11 substances. So we see all these substances prepared in separate containers. This is what you need. Actually, you can try this even at your home. You can try this experiment at your home. So, dear students, sit at home, try to see whether you can get this and see which substances can work as conductors. You can make a man-made switch, anything that completes a circuit. You can have wires which are incomplete and you only complete them by twinning, tying them together. That can work as your switch. You can get these batteries, you can get anils, you can get ethanol, you can go to any shop, get waraji, sugar, you can get urea, you can get paraffin, you can get distilled water, you can get each of these, okay? If you can't get sodium hydroxide, you go to any pharmacy or anywhere, ask for caustic soda, you can get ammonia. How will you get ammonia? Some of these may not have, you can get dilute sulfuric acid, but be careful from those old batteries. Sodium chloride, you can use the common table salt, dissolve it in water. And then you see an exciting experiment if you follow the procedure I'm going to talk about. Okay, so how do you make your setup? This is how you will set up your experiment. First of all, make sure you have your batteries connected. Remember, this is the negative terminal, the short side of, if this is your battery, you know the positive and the negative side, okay? So the negative side should look this side, and then the positive side should be that side. All right, so in case you don't know how to know which one is positive, those batteries, they usually write for you the positive, they usually put signs there to show the positive and negative. So usually they will put here positive, and this side they will put negative. Okay, this side where there is this thing here, it is the positive side, and this is the negative side. So you connect your batteries, 6 of them. No, not 6. We said there are 4, each of 1.5 volts, I think. In case each is 1.5 volts, you connect 4 of them. And after connecting 4 of them, you will get your 6 volts. Now, you bring your connecting wires. Actually, we also need a bulb. We need a bulb, an electric bulb. Okay, I forgot that. We shall need a bulb, a simple electric bulb. Okay, not these heavy ones. Now when you get your batteries, you can get your connecting wires. Okay, this is a connecting wire. Connect it to a battery, I mean a bulb. That's your connecting wire. Okay, get your other connecting wire, which is connected this side. This is my other connecting wire. So if those are your connecting wires that you have that way, you can continue to work out your experiment. Now your iron nails may work as your anode and cathode respectively. So you have the anode and you have the cathode connected to each of those wires. You have this one here, you have this one this side. Of course, this is your bulb. This is your connecting wire. This is your 6 volts DC power supply. Okay, now this being the positive terminal, of course, you will have the anode this side. And this is your cathode, because it's connected to the negative terminal of the battery. Now, finally, complete by dipping that whole setup in you may use a beaker or any bowl in which your electrolyte is going to be. And we are going to keep on doing this experiment by changing our electrolyte. So in here, we have our electrolyte. Our electrolyte is in here. In here, we have our electrolyte. So this is the electrolyte. So that's our setup of the experiment. That is, we are going to use to see whether a substance is a strong, a weak, or in an electrolyte. Hope I can proceed from this step. What's the procedure of the experiment? We've seen the setup, what we need. We're going to have the procedure. So arrange the apparatus. Dear students, arrange the apparatus as shown above. Arrange the apparatus as shown above. Okay, use the setup. Use the setup above to investigate. Each of the substances. Each of the substances. How many were they? 11. Each of the substance 1 to 11 as electrolytes. As electrolytes. Okay. Clean the electrodes. Clean the electrodes using water. So whenever you're going to use another electrolyte, this experiment, whenever you're going to use another electrolyte, for example, you're going to replace sodium chloride solution here with ethanol, make sure you've cleaned these electrodes such that they have no traces of sodium chloride or products formed after electrolysis of sodium chloride on them. I hope that's very clear. Clean the electrodes using water before using the next electrolyte. Before using the next electrolyte. Okay, record your results. We are going to have a table. Record your results in the table below. Record your results in the table below. Hence list the substances. Hence list the substances you have investigated. You have investigated that you would consider, that you would consider, this is practical and can be done in the lab or even at your home in this lockdown, that you would consider strong, weak, or non-electrolytes. How are you going to classify them in terms of strong, weak, or non-electrolytes? It's the bulb that will tell you, okay? Actually, to make your work simpler, this is how I want you to format your table. This is how your table should look like, dear students. Your table should have the solution that you're using as an electrolyte. Should have a solution that you're using as the electrolyte. Excuse my table, I'm not so accurate enough. Then you ask yourself, does the bulb light for whichever electrolyte you use? Okay. You ask yourself that question. Then don't stop there. Do you see bubbles of gas? Bubbles of gas at cathode? How about the anode? Those are questions you should ask yourself. Then ask yourself at the end. Ask yourself. Ask yourself a question. This is the question you should ask yourself. Does it conduct electricity? Does it conduct electricity? Yes, ask yourself that question. Of course, you'll answer those questions after doing the experiment. Let me give you some of my expectations of this experiment. When you use ethanol, these are the answers I expect. Does the bulb light? No. You see bubbles of gas at cathode? No. At the anode? No. Does the substance conduct electricity? Of course, no. Okay. You can even guess the answers by using the theory we talked about on electrolysis. If you use, for example, sodium hydroxide solution, I expect something of this kind. I expect you to have the following as your observations. Sodium hydroxide. If you use sodium hydroxide, does the bulb light? It will light. Yes. You see bubbles of gas at cathode? Yes. Even at the anode? Yes. We shall see what those bubbles represent at each of the electrodes. Does it conduct electricity? Yes. If you use ammonia solution, this is what you'll see. Does the bulb light with ammonia solution? No, it won't light. Do you see bubbles of gas at cathode? You will see them. Do you see bubbles of gas at anode? You will see them. Does it conduct electricity? Yes. But teacher, it doesn't light the bulb. It doesn't light the bulb, but it conducts electricity. So it's upon you to classify it as either a strong or weak electrolyte. Is ethanol an electrolyte? I don't know. Is sodium hydroxide an electrolyte? Yes. Strong or weak? Very strong. Ammonia? Perhaps a weak electrolyte. So I guess you can know the answers for the rest, or if you don't know, try out the experiment. At the end of the experiment, you'll find out I'm going to be using these words. S for strong electrolyte, W for weak electrolyte, N for non-electrolyte. You'll find out that ethanol is a non-electrolyte. Sugar solution, non-electrolyte. Urea would be a weak electrolyte. Paraffin, non-electrolyte. water will be a weak electrolyte. Distilled water will be a non-electrolyte. Cooking oil, non-electrolyte. Sodium hydroxide, strong electrolyte. We find out that ammonia solution is a weak electrolyte. Disulfuric acid is a strong electrolyte. Sodium chloride is a strong electrolyte. Here, ladies and gentlemen, that's the experiment we can use to classify electrolytes as strong, weak, or non-electrolytes. How shall we analyze your results? At the end of any experiment, we should make analysis of the results we get. After you've done the experiment and seen the observations, you classify based on this. 1, all substances that were used, dear students, and the bulb did not light, and the bulb did or does not light, depends on when you're doing the experiment. It won't light and non-electrolytes. Other substances you use and the bulb does not light and non-electrolytes. Secondly, when the bulb produced or produces, depends on the time you're doing the experiment, dim light. Dim light is that faint light, or no light, but bubbles are seen on one or both of the electrodes. On one or both of the electrodes is a weak electrolyte. And lastly, strong electrolytes. Strong electrolytes produced, you find that strong electrolytes produced bright light. Bright light with the bulb. Produced bright light with the bulb. And bubbles were seen at a high rate. Bubbles were seen at a high rate on the electrodes. So that's how that experiment can be used to classify strong, weak, or non-electrolytes. I'll end this lesson by giving you a question. What is my question? The question says, describe an experiment. Describe an experiment to show that ethanol is not an electrolyte, whereas ethanol is not an electrolyte, whereas dilute hydrochloric acid is a strong electrolyte. A strong electrolyte. Diagram is required. Diagram is required. So test yourself by describing that experiment. I've been Joseph Jobs Kaida. Subscribe to our channel after viewing this video. Comment and like or even share. You can reach me on 0753 24 70 98. And reach me on 0753 24 70 98. Bye. Let's meet for our next lesson, which will be lesson 5. In that lesson, make revision about this experiment before we discuss it in that lesson. What we shall discuss in that lesson is the experiment to investigate. It will be an experiment to investigate what happens. Experiment to investigate what happens during electrolysis. You may wonder seriously, why is that bulb lighting, giving off dim light, giving off no light, and giving off very bright light? We shall see really what is happening during electrolysis. Endeavor to go back and do these experiments by your own, or visit any nearby lab or resource center, or even any school. First for what is required and do these experiments. Or even when you go back at school, ask your teacher to help you with what is required to do the experiment. Bye bye.